All right, guys. Okay. So, first of all, we're doing November 2022. That's exam question 5.1. So, okay. This is just a reminder about the number of ways you can have circular arrangements. So, if you had, let's say, 4 people sitting in a row. So, say we have 4 people sitting in a row. How many number of ways they can be arranged? There'll be 4 spaces for the first seat, second, 3 available, 2 times 1. You multiply your choices together. In other words, 4 factorial, which is 24. That's the number of ways you can arrange 4 people sitting in a row. But if 4 people are sitting in a circle, so say you started with the blue arrangement, you had person 1 over here, you had person 2 over here, 3 over here, 4 over here. Okay. If I shuffle, there's no top and bottom in a circle. Can't define, if I move the table around, it's the same position. So the blue arrangement would be the same thing as this red arrangement because the people are sitting in the same relative position. So if I shifted everybody, instead of being the blue arrangement, now I started with the red one over here, person 1 moved to the right, then everybody else moved to the right. So person 2 moved to the right, person 3 moved to the right, in a clockwise direction, 4 moved in a clockwise direction, which would be the sort of blue arrangement, 1, 2, 3, 4, and the red arrangement will actually count as one arrangement. They're not really different to each other because they're sitting in a circle. Okay, if I now took person in position 1 and I shifted everybody across in that direction, then I'd have 1 here, I'd have 2 here, I'd have 3 here, I'd have 4 here. They're still sitting in the same position relative to each other. And if I then shifted 1 and I moved 1 across to there, then and everybody shifted in that direction, you go 1, 2, 3, 4. So all 4 of those color arrangements represent one arrangement. So this, which looks like 4 different arrangements, is in fact in a circle relative to each other. Every 4 arrangement is actually one arrangement. So all 4 colors are the same arrangement, because you get this repetition 4 times. So your number of arrangements of this, well, the number I kind of think of, well, if it was a straight line, how many arrangements could I have? I could have 4 factorial, just like I had 4 factorial arrangements over there. That's the number of ways I can arrange the people. But because of this repetition, I've got to divide by the number of seats, not factorial. Remember, the number of times of repetition is n times, just like over here, the number of repetitions is 4. So it'll be 4 factorial over 4, which is 4 times 3 factorial over 4, which is just 3 factorial. So in general, the number of ways you can arrange n people around a table, round table, would be n factorial over n, which is simply n times n minus 1 factorial over n, which is n minus 1 factorial. So it's that problem of repetition in circular arrangements. So that's your general principle. So in this particular question, well, it says you've got 8 people in the meeting, but the chairman and the vice chairman have to sit next to each other. So the chairman and the vice chairman have to sit next to each other. So let's say that question was a straight line question. So you had 8 people. So this is not the answer. This is for straight line. This is the answer over here. But if you had 8 people sitting in a straight line and the chairman and the vice chairman had to be next to each other, well, this would be an example. You could have person 1, person and 2, chairman and vice chairman next to each other, and then the other 4 people over there. The principle I use for when I've got some things grouped and some things not is your number of arrangements equal to the number of external arrangements times number of internal arrangements. So I basically treat this as a single letter. So your number of external arrangements is going to be 1, 2, 3, 4, 5, 6, 7. I can shuffle those. So it's going to be 7 factorial. And the number of internal arrangements of the group data, I can shuffle those 2 around, and with a number of ways I can arrange 2 people, it's 7 factorial times 2 factorial. But now, this particular question, I'm going to use the same principle, but remember we're working with circular seating. So your number, I'm going to use the same principle. Number of arrangements is equal to number of external times number of internal of the things that have to be grouped together. Now, if you are arranging, essentially these two are stuck together. So you're arranging 7 different things in a circle because those two have to stay glued together. So in a circle, your number of external arrangements is not just 7 factorial, like it was for the straight line. I've got to get rid of that repetition because of the circular nature of the seating arrangement. So it'll be 7 factorial over 7. The number of internal arrangements, so that was the number of external. The number of internal arrangements of the group data is simply going to be shuffling those two guys around. Okay, so it's going to be times 2 factorial. So I end up with 6 factorial times 2, which is 1,440 possible arrangements in for that particular question. Hope that helps.